Hello, so in this video we will talk about planes, and specifically we will talk about the equation of the plane and distance of a point from a plane, and we will add some examples to support our explanation. So let's start with the equation of the plane. So now let's say that we have a point, we know a point which is definitely on a plane, which is like P0, and the coordinates are x0, y0, z0, and this is the plane, P in space, and the vector perpendicular to P is n. Okay, and then any point on a P, x, y, and z, we want to know some equation which has x, y, and z, and x naught, x0, y0, z0, and the coordinates and the properties of the vector n, and then we can use those parameters to find the equation of that plane. Okay, now if P is any point on the plane and P0 is also the definite point on the plane, then what is this vector P0 P? So this is nothing but x minus x0 I, y minus y0 j plus z minus z0. Okay, and which is actually written somewhere here. Yep. Okay, and then since they are perpendicular to each other, because this vector is on the plane, this is on the plane, do you agree? Because P0 is on the plane and P is on the plane, any arbitrary point on the plane, so that means this vector is also on the plane, and then this means that this vector and the vector perpendicular to the plane should be perpendicular to each other. When they are perpendicular to each other, this means their dot product is equal to 0. So now if we define this normal vector as ai plus bj plus ck, then the dot product is what? We multiply the ith component, multiply the jth component, and multiply the kth component, and then we add. Okay, so then this is a times x minus x0, b times y minus y0, and c times z minus z0, and this product should be equal to 0, so this 0 is copied here as 0. So this means that this is our equation of a plane which has a point x0, y0, z0, and a normal vector whose I component is a, whose jth component is b, and whose kth component is c. Okay, okay. So now let's use this in knowledge to find the equation of a plane which has 3 points. This is all we know. Okay, so this means we do not know n, but we know that, let's say this point is x, capital X, this point is capital Y, and this point is capital Z. So our xy vector is what? This is we this is 1 minus 2 I plus 1 minus 0 j plus 1 minus 0 k. How did I do this? I subtracted the x component and subtracted the y component and subtracted the z component for I, j, and k component respectively. So this will give me minus I plus j plus k. Similarly, I can find yz, which is equal to minus I, 1 minus 0 is 1, so plus j, that's it, and 0 minus 0 is 0. Okay, so now we also know that if we find the cross product of this and this, we will get a vector which is normal to both this and this. And we know that this xy is on the plane because x is on the plane and y is on the plane, and yz is also on the plane because y is on the plane and z is on the plane. So the cross product of xy and yz is actually the normal vector for our plane. So first of all we find n, this is equal to xy cross product yz, so which is equal to the determinant I, j, k, and then we will say minus 1, 1, 1, minus 1, 1, 0. So this is equal to what? So for I, we will get 0 minus 1, so minus 1. For j, we will get, so this should be minus, right? So for j, we will get 0 minus minus 1, which is 1. And then for k, we will get 0, because we will have this kind of a matrix here, and both rows are the same. So that's why we have 0 determinant here. So this will equal to minus I minus j. Okay. So now if we compare it with this n, what is our a? So this means a, this is equal to minus 1, b is also equal to minus 1. Okay. And then you can, for point, you can use any of these points. So let me choose z here. Okay. So then what is the equation of the plane? It is minus 1, because this is a, then x minus 1, then minus 1, y minus 1, and plus 0, plus 0, z minus 0, this is equal to 0. So then minus x plus 1 minus y plus 1 is equal to 0. So I can say minus x minus y plus 2 is equal to 0. So this is the equation of the plane I am looking for. Okay. So then we have done the equation of the plane. Now we come to another topic. We want to find a distance from any point to any plane. Okay. So let's say we have this point E, and we have this plane, this plane is our P. Okay. And this is the point P0 on it, which is x0, y0, and z0. And then this is the normal vector. So this is the normal vector here. So then if I draw it like this, and this is the right angle here, and then we have a triangle like this. Okay, so now let's read through it and see whether this makes sense or not. So then we have a plane P, and which is defined by point P0 and the normal vector n, as we have done in the previous case. Now we are interested in the distance between the point E and the plane. Okay, now let Q be the point on P such that EQ is perpendicular to P. Now you can also appreciate that EQ has the same direction as n, because n is also perpendicular to P. Now we want to find the length of this EQ, because this is the distance of E to the point, to the plane. Okay, then n and EQ are in the same direction, and using the dot product. Okay, now this is a right angle triangle. Now this means that if I say EP0 dot product of n, but n, not any n, we have to divide it by the magnitude of n. So this is the unit vector here, unit vector in the direction of n. Now if I find the dot product here, this will give me this EQ. Okay. So then again, using the properties of dot product, we know that if we take the dot product of, if we have to find the projection of any vector onto any other vector, what we find is, we find the unit vector of the vector on which we want to find the projection on, and then we take the dot product of the other vector on that unit vector. Okay, so then just read through it. Using the definition of dot product, in the right triangle PQ, P0, QE, we find the magnitude of EQ by taking the dot product of EP and the unit vector in the direction of n. Okay, now what is the unit vector in the direction of n? This is nothing but the unit vector itself divided by the magnitude here. Okay, divided by the magnitude here, and the distance, then the dot product of what is. So this is just a scalar here. If we take the dot product of this guy with so what is P0E? Now this E is what? X, Y, and z, or maybe x1, y1, z1. So what we want to find is, we want to find this guy is what? X minus x0, I, y minus y0, j, and z minus z0. Okay, plus and plus. Okay, so this is exactly, if we want to find the dot product of this guy and this guy, we will get a x minus x0, b y minus y0, c x minus z z0 divided by the magnitude of n. So this is the distance of the point x, y, z to the plane who has the point x0, y0, z0, and the normal vector is given by ai plus bj plus ck. Okay, now let's use this knowledge to find the distance of the point this to the plane this. Okay, so now we do not know the point, so we don't have p0, but we can find p0, right, by arbitrary values of x and y and z. So let's say we want x 0 0. I do not know what is x, so I'll just plug 0 and 0 for y and z and find x here. So this will give me 3x plus 1 equal to 0. So x is equal to negative 1 over 3. So my point is negative 1 over 3, 0 and 0. Okay. Now this is, now I have everything now. So I have x, y and z. I have, this is my a, this is my b, and this is my c. Okay, so now I will just, all I have to do is plug it here. So the distance is what? So this is, a is what? 3 times 2 minus 1 over 3. So 2 minus 1 over 3 plus 2 times 0 minus 0 plus 8 times minus 1 minus 0 divided by 3 squared plus 2 squared plus 8 squared. So this is equal to 6 plus 1 minus 8 divided by root 77. But note that this is a distance, so we have to take the absolute value here, and we have the absolute value here as well. Okay, so then this is equal to 1 over root 77. Okay, okay, so then what we have learned so far is find the equation of the plane and to find the distance of any point to that plane. Okay, for that plane we need a point on that plane and we need the normal vector on that plane, and any plane can be completely defined by one point and the normal vector to it. So hope it was easy to understand, and thanks for watching. Hope you liked the video.